Look around yourself. You will see multiple rotating objects, the hands of a clock, the blades of a fan, a pin wheel, or a spinning dartboard. Now, do you observe one thing which is common in all of these? There is one point which is not rotating. It is fixed. Such a fixed point around which the object rotates is called center of rotation. Now, let's observe the hands of a clock. This is the second hand of a clock. While it moves from 12 to 12 to complete 1 minute, it moves a full circle. And by doing that, it covers an angle of 360 degrees. If it moves from 12 to 6, it will cover half a circle. That is half of 360 degrees, which means an angle of 180 degrees. Similarly, if it moves from 12 to 3, it covers quarter of a circle. That is an angle of 90 degrees. This angle of turning during rotation is called angle of rotation. Now we have a square over here. How do we find the center of rotation for this square? Finding the center of rotation for circular objects is relatively easier because we can pinpoint the center. But how do we find center of rotation for a square or a rectangle or any polygon? So what we can do is, we can start by drawing the lines of symmetry. So there will be this one line of symmetry and another one vertically and two lines of symmetry diagonally like this. Now the intersection point of lines of symmetry forms the center of rotation. So this red dot is the center of rotation for the square. Now let us rotate the square clockwise by 90 degrees. If we do that, it will look like this. So the AB side, which was here after rotation, has come over here. I have just put on the vertices to highlight how it looks after rotation. But ignore the vertices for once and just look at the squares. You will see that they are identical. They look exactly the same. Let us rotate this one more time, again by 90 degrees clockwise. After that, it looks like this. Now, we'll do third rotation by same angle in the same direction, and it looks like this. After the fourth rotation, it will cover a complete circle of 360 degrees and will look like this. It is back to its original position. Now, again, ignore the vertices and just see that this looks similar to the initial one. At every rotation, the square was exactly the same as the square was before rotation. So, in a full turn of 360 degrees, there are 4 positions, 1, 2, 3 and 4, where the square looks the same. So, we say that the square has a rotational symmetry of order 4. Its order of rotation is 4. What is rotational symmetry? Whenever we rotate an object at certain angle of rotation, if it looks the same as it was before rotation, we say that it is showing or depicting rotational symmetry. So the order of rotation is the number of times an object looks the same during a full 360 degree rotation. Let us take one more example of an equilateral triangle. In order to find the center of rotation, we'll draw the lines of symmetry. So we have the center of rotation, which is at the intersection point. Now I need to find the angle of rotation. So if I rotate it clockwise and this vertex comes to this point, it will show rotational symmetry. It will look the same. So I need to find this angle. And let's just see that there are 1, 2 and 3 such angles. So 360 divided by 3, which is 120 degrees. So let us rotate it 120 degrees clockwise. Once we do that, it will look like this, exactly the same. Let us rotate it one more time and it will look like this. After one more rotation, when it covers a full circle of 360 degrees, it looks like this. So the order of rotation of an equilateral triangle is 3. Now let's take one final example where we will be finding everything: the center of rotation, the angle of rotation, the order of rotation. So this is a star-shaped figure. Let us find the center by drawing the lines of symmetry. There are so many lines of symmetry here. So this intersection point is the center of rotation. Now again we need to find the angle. So I can see, upon observation, we can see that if this point moves over here, like overlaps, it will overlap, it will coincide, right? So it will show rotational symmetry. So I need to find this angle. Similarly, this can move over here. So there are 3 and then 4 and 5 and 6. So 360 degree divided by 6 is 60 degrees. So let's rotate it by 60 degrees clockwise. It looks like this after first rotation. Let us rotate it one more time and it looks like this. So after the third rotation, it will look like this. Then one more time, it looks exactly the same. We have fifth rotation and it looks like this. After the last rotation, when it completes a circle of 360 degrees, it looks like this. So we rotated it 1, 2, 3, 4, 5, 6 times. So its order of rotation is 6.